Hello, Joshua. September 21, 2020. How are you?
I'm good.
Differentiate the following using the differentiation formulas and the law method. Are you ready?
Yes.
Okay. For the first problem, differentiate y is equal to x squared minus 2x. Use the differentiation formulas first.
So to solve this, there are two things that are here. So there's the power and there's a minus. So for here, for this, we're going to use the derivative of sum or difference and the derivatives of power is the power formula. So if we have this derivative of u plus minus b, that will equal du over du dx plus minus dv dx. Okay, so there's also one more, it's the power formula. Okay, so
Right here.
all right, so let's start. So here we can see that this u plus b is x squared minus 2x. So using this formula, we can see that this is actually this d dx x squared minus d dx 2x. Okay, so as you can see here, there are powers. There's 2, and then there's also 1. It's not shown. There's a 1 here. So from there, we can see that n equals 2 here is 2, and n equals 1 here. So for this, you can see that the n will be multiplied to the everything first. So this will become 2x, and then 2 minus 1. And then here, 1 times 2, that is just 2, and then x to the 1 minus 1. Okay, x to 1 minus 1 is x to the 0, that's also 1. And then here is x to the 2 minus 1, is x to the first power, that's just 2x. So 2x minus 2, actually it's times 1. But okay, so it's the answer.
Okay, use the next stage for the law method.
Alright, so the problem again was
Y is equal to x squared minus 2x.
Okay. For the long method, you will have to turn this y into y plus delta y and then the x into x plus delta x because the position has changed. So it's the new position. Okay. So as you can see here, there's this y, and then we already have this equation for y. So we can substitute y. So I'll just transpose this y, or I can also subtract y from both sides. It's the same thing anyway. And then we will substitute this equation for it. So
One step at a time, so it's a bit clear.
minus y. So I can substitute this for this. So I can also expand this at the same time as I substitute. So I'll expand this to become x squared plus 2x delta x plus delta x squared. And then minus 2x minus 2 delta x. So let's substitute for this. Be minus 1t x squared minus 2x. Okay, we can remove the parentheses. So to remove the parentheses, we invert the signs. So the positive here is not shown in the x squared and just become negative. And then this negative will become positive. So flip it. Okay, there are like terms in here. So there's this x squared. There's also an x squared here. Negative x squared. And then there's this 2x. Here's the negative 2x. Okay, here's the negative 2x. Okay. So we can count. I use this right here. Okay. We can cancel this x squared and we can also cancel this x squared. Which is negative 2x. We can cancel it with this positive 2x. So maybe you can actually see that all of these have delta x in them. There's a common factor. So we can divide it out. For those of you who don't know, it's very easy. You can just split this up. Oh, but it's not equals. It's supposed to be equals. Okay. We can cancel some stuff. We can cancel this. So we cancel. So all in all, that will just equal 2x plus delta x minus 2. So here there's a limit. So the limit is delta x approaches 0. So as this approaches 0, this delta x in here, of course, is going to disappear. It will just become 0. So nothing. So this is just equal to 2x minus 2. Wait, let me see. So yes, we also see 2x minus 2. So this is correct.
So how will you write that one? Is that still delta x over delta delta y over delta x?
Well, the problem is since we've already turned this delta x into a limit, it means these deltas are actually infinitesimals already. So
write them
instead of
all,
being
written.
a big delta, just turn it to a small d. In older books, they just use the lowercase delta, but it's not used anymore. So 2x minus 2. So final answer.
Okay,
Right.
that's correct. Let's go to the next problem. Can you use the mouse to
All right.
X? Yeah. Okay.
All right. We have a new
Okay.
page.
New page. Okay. Number 2. Second problem is y is equal to 4x squared minus 3x minus 2.
Okay. So here we have one more sort of identity or a differentiation
One more
formula
time.
to use, and that's a constant. So
So right there the formulas that you're going to use.
So first of all, we'll use, of course, the plus minus, the sum or difference. I'll just rewrite them. So also have the power formula, of course. So oh, here we go. It's not really in. And and finally, for the constant term,
Yes, also
d over
derivative of a
dx
constant.
c is for constant. That's equals to always 0. Why? Because it's actually the c here is actually has been a proof of that. So for all constants, so it's solved already. So be 0. So d over dx y is okay. So we use this plus minus or this the sum and difference. So here we can see the derivative of constant is 0. So just become 0. And then here you can see there's this we just annotate this n equals to, move that here, it will become 8. It's 2 times 4 and then 2 minus 1. And then here, this is actually n equals 1. There's this 1 here. And then here, this will just all become 0. So we got 2 times 4 is 8. And then x to the 2 minus 1. That'll just be 1. But we'll do that later. So 3x, 1 times 3 is 3. And then x to the 1 minus 1. So 0 only. And then 1 0. So I don't know. So that will just be 8x because 1 minus the 2 minus 1 is just 1, so we have to delete that. Then x minus 1 minus 1 is 0, so it should be 1. So there should be x minus 3.
Okay, so can we turn to the next question?
Um,
Go to the next page.
yes, okay.
Please go long method. Rewrite the problem. Y is equal to 4x squared minus 3x minus 2.
Okay, long method. Now it will get kind of tedious because there are many x's and many y's, but it's okay. What is that? Let me start again here. 4x plus delta n times 3. Same as usual, but now we can also again substitute this y for this. Okay.
Therefore,
I'll
we
just
recognize correct check this one. It's an ISO. Perhaps
So again, we can substitute it here.
Okay.
So delta y equals expand this one more time. So plus 8. So
You can do vertical to combine like terms, okay?
yeah, it
Vertical
will kind of look
computation.
pretty much. It's hard to find some of the terms sometimes. The equation becomes long. So this one, oh okay, it's an error. It's supposed to be 4 delta x squared. Yes, okay. So instead of doing this here, it would be hard to find. So, oh wait, actually, as we can see, the signs here are positive, minus, and minus. Minus. We don't need to flip the signs now because. So 4x minus 4x equals 0. And then so become 8x dot x 4 dot x squared 0 minus 3 dot x. And then 0 again. So this is it. Again, you can see that there's still a delta x in all of them. There's still a common factor. So delta y over delta x. All over the x. Here, it has this, plus cancel this. So we can everything. So again, delta x will again be approaching 0. So this one is gone. This one becomes 0. So cancel. So all in all, I'll just put here. This will again be 2y dx.
Define it.
So again, here's the infinitesimal dy dx. We don't use the capital D. These are big changes. These are infinitesimal changes, very small changes.
Louder.
So 8x minus 3. Let's see our other one. 8x minus 3, and then
Same answer.
8x minus 3. Same
Very
answer.
good.
It's correct. Next page.
Next page. This time, it's, x is equal to 1 over
All right. So now we will have a different kind of a new approach to this. So there are two ways to think of 1 over t. That is all. That this also t to the negative 1. But also instead of having to deal with those negative 1, negative 1. Okay, actually we will make two solutions for that. But there's another equation for this the differentiation formula. That is for d dx
what do
u
you call it?
over
Derivative of
derivative of quotient, hopefully. So derivative of quotient.
derivative of
So this is a little more complicated, but hopefully you can still understand. So I'll just write this and then I'll explain to you what this all means. So apparently, this one is the square of the denominator.
Right there, square the denominator, b2. B2, we can see it's B2 already. So what do you mean by
So here,
g times du over dx?
this one, this v times du dx. That means the denominator, which is v,
Denominator times,
times the derivative of u with respect to x again.
what's u? Derivative of
Derivative of the numerator.
Yes.
So all in all,
Minus,
it's denominator times derivative of the numerator minus the numerator times the derivative of the denominator,
okay,
all over the square of the denominator.
okay. So
All
can
right.
you
So
start solving like that?
d dx what will it be? So that equals over t squared. So of course we have to do this. So again, denominator times the derivative of the numerator. So it's t and then d dx 1. What's d dx of a constant? It's 0. So then all this will be 0. I'll just put that in the next equation. Minus u, which is the numerator. Is
No, it's only silence.
1 times d dx. So all that equals. So again, I said that the derivative of constants always zeros. So they'll just be all 0 minus whatever this is. So the derivative of t, so d dx t, that's 2t to the first power. So 1 times t, again t, and then 1 minus 1 minus 1, that equals 0.
Right here.
So it turns out all of this derivative of any variable as long as it's raised to the first power, it'll always be 1. There's 1, 1, all over t squared. So this equals 1 over t squared. All right. So this is, okay, so like this.
So can you solve that using the long method?
Using the long method. Okay, so now we'll still
1 over,
1 over x.
no, oh, wait,
Oh, it's 1 over t. Yeah.
yes. Wait,
So I'll just okay, it's correct anyway. So
x is equal to 1 over t.
okay, so x equals 1 over t. We will, instead of the familiar y plus delta y, we'll still add the delta. Still x plus delta x equals 1 over t plus delta t. Okay,
We can remove the
now
parentheses here to serve no purpose.
we can see that we can do nothing already because you don't have to we don't have to expand it. So instead I'll just transpose this x again or subtract x from both sides minus x, and we substitute again this 1 minus t into the x. So delta x equals 1 over t plus delta t minus 1 over t. So now we have another concept. So this is the LCD. The LCD of both of these is t times t plus delta t.
Make the fraction line longer.
Of course, do. So now, we cross multiply, or instead, if you want to do it, so 1 over, okay, wait, so 1 over,
No, you should
okay.
show it.
So anyway, 1 over t times delta t, if you make it like this will become t, and then minus quantity t plus delta t.
Consider that, yeah,
Pardon
it's
my
second.
writing. Okay, let's put t. Okay, so now we can eliminate the parentheses. I also expand this denominator. So there's obviously a common term like terms two. So there's t minus t minus 0. So all in all, that equals negative delta t over t squared plus t delta t. Okay,
Can we continue above?
so there's not
Next
much
time-
room anymore.
Next time you transpose on the
Yeah.
use
So
the space.
negative delta t.
Therefore, with how you write the T, it looks like a plus.
Okay, so this is delta x. So again, there is another common multiple. That's again delta t. So we can divide delta x over delta t.
Well, here, make it here.
Okay,
Don't do that.
delta x.
Make it nice.
Okay, so this would be a big fraction. Over. So we can flip this. You can find the reciprocal of delta t. That's 1 over delta t, and then we multiply it with this big fraction. So it will be negative. So here we know that we can cancel. Just do it. Cancel this. So that equals negative 1 over t squared plus t delta t. So the limit is delta okay, so this dx dt actually. So the limit of delta t approaches 0.
Not yet, huh? Not yet infinitesimal. There's still delta T
Oh wait,
here.
there's the delta t. Okay, so delta t approaches 0. So this 0. So 0 times t obviously is again
Yes, again.
0.
0, you see it.
So
It's not understood.
Let's move this side. Okay, so this equals to -1
Oh,
over
no.
t
What is
squared.
that? That's my delta t over t.
So
Be careful with the conventions of
-1 over t squared. -1 over t squared. Ah,
yes, we have the same answer. That's correct. So let's go to the last problem. Problem number 4. And y is equal to square root of x.
okay, now.
Can you use the differentiation formulas first?
So there's no differentiation formula for roots. There's actually one for logarithms, but not for roots, because roots can be expressed in fractional powers. This all equal to x to the 1/2. So again, remind you to the power formula. Okay, so if we find the d dx y, that will just be, okay, so now we'll have a harder problem. So that would be 1/2 x plus n equals 1/2, n equals 1/2. Okay, n equals 1/2. So 1/2 x to the 1/2 power minus 1. So what's 1/2 minus 1/2? 1/2 minus 1 is -1/2. So okay, so when it's negative, it means the x or the variable will be in the denominator, or vice versa, if it's in the denominator, be in the numerator. And then when it's 1/2, of course, it will be a square root. It's a
You mean to
fractional.
say it's the reciprocal?
Yes. Okay. So 2 square root of x. It's in the denominator, and
Before
it's
it
a radical.
became square root of x, show us before it became, so the students watching can follow you step by step. I know you know those, but some of the viewers might not know.
Okay.
Yes.
So back this up so you can refer later.
So go to the next page, and that is y is equal to square root of x. Use the law method this time.
Okay. Now this will be a little harder because there's a square root. So now we can simplify this again. So we will transpose this y into here. And again, we can substitute this square root of x into the y. Okay,
So what do
so
you do now?
so you may think, how do we simplify this? Okay, so it's possible to simplify this and use conjugates. So this will be equal to, so multiply everything by its conjugate. So here, there's the a minus b times a plus b. For those who don't know, that's equal to a squared minus b squared. So here, we're going to do x plus dot x squared minus square root of x squared. We all know that's just x. I'll still do that later. So this is all over x plus root x plus square root x. So if we simplify this, we remove the radical on this one, this term. We remove the radical, so that will just be x plus dot x. Then from this term, we also remove the radical, so that will just be minus x all over square root of x plus dot x plus square root of x. So this equal to dot y. Right, so I hope you understood this. So we have to erase this so we have enough space. Okay, so here there's this like term, so you can cancel this already. Alright. Okay, so despite what you see that there's not no common factor of dot x, we must still divide this by dot x, so we can do the derivative. Multiply this by 1 over dot x or whatever. It's be 1.
Oh, show us step by step.
Okay, so now again delta
Delta y
x.
over delta x becomes what? Here,
Okay.
below first.
So
Show us first.
delta y over delta x.
We're not inside your mind. Look everything clear.
Okay, so again delta x approaches 0. So this term inside becomes 0. So that'll just equal up plus a like term. So we'll just combine that. This all equal to 1 over 2 to the delta x. Oh, over delta x. You see the answer? Well, 1 over 2 to 2 squared x.
Yes,
So
oh, delta x is approaching what? You do not write. Write everything is written.
All right. So
Thank you very much, Joshua.
thanks for watching.
Thanks for watching. Good job.